Hi dear students, the topic of today's session is that how are we going to convert an image to binary? Or in other words, we can say that how are we going to save an image into the computer? Definitely image is in form that cannot be stored in the computer. So we need, whenever we want to store it in the computer, what computer does for us is that it converts it into binary. So you can see an emoji on the screen and it is a monochrome image. Monochrome means that it is a black and white image. So this picture is or this emoji is clearly showing up that how images can be stored inside the computer. So let's start. You can see here that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bits are being stored uh, in row wise and in the we have 9 columns and 10 rows. In other words, we can say that if this image is 9 bits wide and 10 bits high, like this is the height and this is the width, right? So whenever we are calculating the number of bits being used to store an image is known as image resolution. So here you can see the definition of image resolution as well, that what image resolution is saying, the number of pixels to make up an image. So as this was a very simple image, so in quite larger images, you can see the image resolution here is 4096 into 3072. It means that it is made up of that much number of pixels. Okay, now the question comes into our mind that what pixel is. Although you must have heard this term while while storing pictures into your computer, but what does this pixel mean? So, what is a pixel? So, the picture element that is being used to store the smallest unit of a picture or small dot representation of a picture is known as pixel. So the smallest definition or a clear definition of pixel is that it is a picture element that is used to represent the whole picture. Now we can just thrash this image more. You can see here that bits are only on here. You can see here that we have this bit. There is no data here, no data here, and then we have different bits here. So if I write it, so what should I write? 2 white. And how many blacks are there? 1, 2, 3, 4, 5. 5B and then 2W. And vice versa, we are going to write it for the next row as well. Hopefully you got the idea of what is pixel. A smallest unit of picture is known as pixel, and image resolution is number of bits in height and in width. In width and in height is known as image resolution. So let's proceed to solve a question. Here you can see that you need to fill this grid. So how are we going to fill it? 3 whites, 2 dark and 3 whites, right? Or rather than we will write 5 whites, because from counting here 1, 2, 3, 4, 5 whites are here. Then 1, 2, 3, 4 blues are 4 black are here. Then 1, 2, 3, 3 whites, and so on. Hopefully you will be getting the idea that how are we going to write this picture in the form of whites and blacks, right? So further we can also write it like this, right? Rather than writing is 3W, we are going to write is 3 zeros. And for dark, sorry, it's not B, it's D, dark and white. They are representing it with 2 colors. W is for white and each dark square is represented by D. So 3 whites and can be represented with 3 zeros and 2 1. 1 is representation of this bit and 0 is representation of this bit. So in this way we can convert this number to be stored inside the binary format. So let's proceed further with the colored images, that how are we going to store the colored image. But before getting into the detail of colored image, I would like to introduce one more terminology that is known as bit depth. What is bit depth? The color depth is the number of bits that are used to represent each color. So you can see here that the number of bits we are using to store a color is known as bit depth or color depth. For example, if we are using 8-bit register to store the colors, so we will be having 2 power 8 range of colors and vice versa. Here you can see in the images as well that in 8-bit color scheme, then 16-bit color and 32-bit color. So more the color depth or bit depth, more the image will be sharper. So it is in fact directly proportional to our sharpness of the image. The more clear the image is, the more color depth it have, color or bit depth, right? Okay, so here we can take an example of colored image. You can see here in colored images, we have, this is an RGB image, red, green, blue image. And here you can see for each color, we have a associated code. For black, all these components of RGB are 0. For white, they are attaining their maximum value to 55. Then for green, it's 0 to 55, 0. And for red, it's 255, 0, 0. So if this combination has been given to you, so it's very easy for you to interpret an image into binary format. Okay, Ji. Along with that, I would like to introduce one more idea here, that how are we going to measure the file size. Either it's your audio file, either it's your image file. So for that purpose, we need to memorize P of the storage unit, and the smallest storage unit is bit. I have discussed this term many times during my lectures. Bit is single storage. Like you can store either 0 into it or either 1 into it. So this single storage location is known as your bit, and in bit we can store data either it is 0 or 1. So 4 bits when combined together, these makes a nibble. And when 2 nibbles means 8 bytes are combined together, these are making 1 byte. And the larger units of bytes are kibibytes. Kibibytes is similar to kilobytes or kilo units, and we are going to write it in the form of 2 power 10. Then megabytes is your 2 power 20. Gigabytes is your 2 power 30, and etc. 50, and this is your 2 power 60. The discussion about how can we convert different storage unit into another storage unit. For example, if I want to know that how many megabytes are in 1 kilobyte, or in 1 kilobytes how many megabytes do we have, so it's very simple, just like our SI units, but we will solve this question into our next class, inshallah. Till then, keep watching my video and subscribe my channel. See you in next session, inshallah. Allah Hafiz.